Well guys, it's time for our STAR 2019 review video. Okay, so this is like a crash course of Algebra I, just to remind you guys what all you already know. First up, we have linear. So on your STAR today, or whatever day you're watching this, remember we're going to be talking about linear. And when we have linear, we talk about lines. Most of our lines are y equals mx plus b. Whenever we have two lines out in space, we have what we call a system of equations, and that's when you have more than one. And you're looking for, where do those lines cross? Your lines could cross in one spot, or they could be parallel lines which have no solution. They never cross. You also have lines that are exactly the same on top of each other, and those cross in infinitely many spots. All right, when you solve equations, sometimes we get something like maybe 4x plus 2 equals 4x plus 2. And you're like, wait, that's the exact same thing. Or we might say 2 equals 2 because the 4's would cancel out. So they equal exactly the same thing. Now, when you get this situation, the same thing on both sides, remember that is infinitely many solutions. The other option is, let's say 4x plus 1 equals 4x plus 5. Wait, those are different. So we would say 1 equals 5. Ooh, that is not true. This would be no solution. Two different scenarios there. We also have a lot of different forms. One is point slope, y2 minus, we'll say 3 times x minus 1. This is called point and slope. The slope is 3. And the point on this, we've got 1 and 2, and remember they would be the opposite, but it wouldn't matter. We would graph that on our new friend Desmos, and we could find out different points on this line. So you've had a lot with linear. Now, we also have had quadratic. With quadratic, those are those parabolas that are either happy parabolas or sad parabolas. Parabolas have a vertex. It's at the top or at the bottom. And remember, they have that beloved axis of symmetry that has the letter x in it, and the axis of symmetry is x equals. The axis is like a car axle, and it divides our parabola right down the middle. This would be a minimum. This would be a maximum. Quadratics have x squared in them. Everything on quadratics we use Desmos for, so enjoy Desmos this year. Our last one we had was our exponential. And I just want to remind you about our friend P-Man. If you haven't met P-Man, I'm going to introduce to him over the next second. If I have something like x squared cubed, and I ask you to simplify that, it's like, oh, am I adding those exponents? Am I multiplying? What am I doing? P-Man says if you have parentheses, so if you have x squared cubed, he says you multiply the exponents. So 2 times 3 would be x to the 6th. But then sometimes I have x squared times x to the 3rd. So I'm multiplying those exponents. So x squared times x to the 3rd. When you multiply the bases, P-Man says you add the exponents together. So 2 plus 3 is to the 5th. Now sometimes you have x squared plus x cubed. So it will look like this, x squared plus x to the 3rd. That's like, well, what does that equal? Well, P-Man says if you are adding the bases, you do nothing. And you're like, what? I can't put those together. There's a wall separating them. They aren't in the same family, so they can't get to each other. So my answer is just x squared plus x to the 3rd. P-Man, he is our friend. Exponential functions, they look like this. They are either growing or they are going the other way and decaying. There's a line on here, and he's an asymptote of himself. You're like, what? Remember this word, asymptote? Asymptote has the letter y in it, so it's y equals. The asymptote is the line that it gets really close to, but it never touches it. In our case, this one right here is y equals 0. Exponential functions are y equals ab to the x power. Remember, a, it's the starting point. It's the y-intercept. Very important to remember, it's the starting amount. And that is a quick recap for your star today. Good luck, guys. I know that's like a 5-second cram session. Thank y'all.